Good day. Welcome back to our YouTube channel. If you're new here, don't forget to subscribe so that you can get great content from us like this. So previous days we dealt with the periodic table, and we also dealt with alkanes. So today we are on alkenes, right? Alkenes. So what are alkenes? So these are unsaturated hydrocarbons with at least one double bond between carbon atoms, right? So they have at least one double bond, right? So the functional group of this, is a double bond between carbon atoms, right? So this, if you want the structural formula of the functional group, that is the structural formula of the functional group. So you always remember that by at least one single bond between the carbon atoms, right? So what else? So these alkenes, they have the general formula of CnH2n, like that. So it's different from that of alkanes, right? But nevertheless, these alkanes, when you try to name them, we name them exactly the same as we are trying to name the alkanes, but their names always end now with E, N, E. So this is the suffix that we use on alkenes, right? The suffix of alkenes is E, N, E. You remember those are prefixes that we used to use like from the last session, right? So it's still the same. We use that suffix, that prefix, and this suffix, right? Okay, but now when you're naming the alkenes now, it will be a bit different because we want to mention the position that this double bond is at, right? Just like we were doing when we were having the branches on alkanes. Also on alkenes, we are going to apply the same rule, right? So let's see how we do this. So how do we name these alkenes? So I said when naming alkenes, I always remember the ENE, right? So we identify the parent chain or the longest chain that is having that is including the double bond. Just for an example, if we're having something like, right, and we're having a double bond there, remember that carbon will always have 4 bonds, right? Don't make a mistake to give it 5 bonds. Don't make that mistake of giving it 5 bonds. It's always 4 bonds like that. So maybe we're trying to name this alkene because you can see that it is having a double bond there. Can you see that? Yes. So how do we name this? We identify the longest chain, which is the parent chain. So this is the parent chain, right? And then the next thing, now you number your carbons from the side that gives the double bond the lowest number. So obviously we are going to start from this side, which is the one closest to the double bond. So we are going to say 1, 2, 3, 4, 5, right? So after numbering your carbon like that, it means that now we are going to use the prefix we were using on alkanes, right? So if it is 5 like this, we know that that is, if it was an alkane, it was going to be a pentane, right? So now how do we do it with this like that? So it means that now we name the prefix first, which is the pent, right? And now just because this double bond is coming on carbon number 1, so we put a hyphen, because between numbers and letter we put a hyphen, right? So 1, and then the suffix of alkenes we said is ene. So that's the name of this right there, right? Pent 1 in, like that, right? So maybe let's try another one again. So let's try this one out. So again, like we did on the previous one, we first identify the longest chain, which is the parent chain, right? So this is the longest chain, the parent chain, and we are going to number the carbons from the side closest to the what? To the double bond. So obviously this side is closest to the double bond, right? So this will be 1, 2, 3, 4, 5, and 6, right? So how do we name it? First, we put the prefix of this. The prefix of 6 carbons is hex, right? So we're going to start with that hex, right? And this double bond is coming on carbon number 2 there. So hyphen 2 hyphen the suffix ene, and this is the IUPAC name of this compound, right? This molecule will be called hex2 in, like that. So you just check where the double bond is at, and you number your carbons from the side closest to that double bond, right? Like that. Maybe let's do one more, and then we can move to branched alkenes, right? We can move to branched alkenes after this. So let's see with this one, right? So again, we identify our longest chain, right? So this is the whole longest chain, 1, 2, 3, 4, 5, 6, 7 carbons. That's hept, right? That's hept. And then we number our carbons from the side closest to the double bond. If we count from there, it's 1, 2, 3, 4. It's coming on carbon number 4. But from this side, it's 1, 2, 3. It's coming on carbon number 3. So we number from this side, right? And then now it is coming on carbon number 3, right? So hyphen 3 hyphen ene. That's the name of this compound, just like that. It's very easy, right? So now let's proceed to go to branched alkenes. Then you can go to alkynes, right? So now, how do we name these branched alkenes now? How do we name these branched alkenes? So naming these branched alkenes, what we need first, like we said, it is to identify the longest chain that contains, don't forget, that contains the double bond, right? So if you're having another longest chain but without the double bond, it means that that's not the longest chain. You need to always pick the one that is having the double bond in between, right? And the second thing that you can do from identify the longest, now you number carbon atoms from the side that is closest to the double bond. So at this point now we are not minding the what? The branch. The side that we are picking must be closest to the double bond, right? Because the functional group is of more importance than the what? Than the branch. So the functional group is more important than the what? Than the branch, right? So that is more important than the branch. So we prioritize the functional group first, right? And then from that, it means that now you name the same way that we did. We are going to combine everything we did on naming the branched alkanes and also with naming the alkenes, right? So let's see. So you see here we are having this branch that is going like that, and we are having this that is going like that, but this or this, we don't consider them because there's no double bond in here, right? So it means that it's either be this or that or that. So let's see which one is the longest chain. So if we go like 1 2 3 4 5, it's 5 carbons. 1 2 3 4 5 6, it's 6 carbons. 1 2 3 4 5 6 is 6. So it's either we are going like this or we are going like that. It depends on what you want, right? So which side is closest to the double bond? Obviously this side is closest to the double bond. So let's number our carbon atoms. So there are 6 carbons in the longest chain, right? 6 of them in the longest chain. So what do we do now? So we are going to identify our branches. We are going to identify our branches, right? So this branch at carbon number 5. So at carbon number 5, we are having a methyl. And on carbon number 3, we are having ethyl. And lastly, our double bond is coming on carbon number 2. So our double bond is coming on carbon number 2, right? And what is the longest chain? We said it is 6 carbons, and 6 carbons, we know that the parent name will be hex, right? That's the parent name. So how are we going to put out this name as one now? So remember when we said we name the branches first. So we are going to start with naming the branches first, and we are still following those rules that we're using on alkanes, right? So obviously E comes before M, so we're going to start with 3 ethyl, right? And then hyphen 5 methyl, right? And the parent name X, right? And on carbon number 2, we're having a double bond, which is represented by E and E like that. So that's the name of this compound, right? The name of this molecule is 3-ethyl 5-methyl X2 in like that, right? So let's try maybe another one, and I'll give you something else to try on, right? Okay. So how to name this one? Do you want to try this? If you want to try this, you can pause the video and work on it. So I'll resume and give you the solution in 3 2 1 go. Okay, so the solution to this means that again we are going to apply the same methods, right? We identify our longest chain, that is including the double bond. So this is including the double bond. So 1 2 3 4 5, or 1 2 3 4 5. So either way it is still the same, right? And then we number our carbon atoms from the side closest to the double bond. So if we number like this, 1 2, this is closest to the what? To the branch. 3, and carbon will come on the double bond will come on carbon number 3, but from this side it's 1 2, double bond came on carbon number 2 3 4, and this came on carbon number 4, right? So we will choose this side. We will prioritize the double bond more than the branch, right? So we are numbering from this side, right? So now, how do we name this now? So we start with the branch. So this is branches come on carbon number 4, which is a methyl branch, right? So 1 2, the double bond, so it's actually 2 as our suffix, right? And the parent name is 5 carbons, so it has to be pent, right? So now how do we put the whole name together? I said we start naming the branch. So this is 4 methyl, right? And then branch, sorry, after this it means that we are coming with the parent name, there's no any other branch, so pent, and then 2 E-N-E. So that's the whole name like that. Can you see that? Very easy, right? Yes. So this is how we name the alkanes and branched alkanes. So I'll just continue to go on alkynes, because alkynes are very similar to alkenes, just a difference of a double bond and a triple bond only, right? So We are here at last. So what are alkynes? So alkynes, they are also unsaturated hydrocarbons with at least one triple bond between carbon atoms, right? So they're having at least a triple bond between their carbon atoms. So they are unsaturated, and the functional group is just triple bond like that, right? And also the general formula is CnH2n-2. That's their general formula, right? So let's continue on alkynes, right? So what else do we have to know about alkynes? So also the suffix in their name now, unlike alkanes and alkenes. So now these alkynes, we have YNE. So this is the suffix of alkynes. This is the suffix of alkynes. So we are just going to adopt the same methods we were using when we were dealing with alkenes, right? How to name the alkenes is also the same way that we name the alkynes, right? So don't forget that every time I'm telling you to draw, to write the name of something, it means that also at the same time you'll be also learning how to draw, because naming is more equivalent to naming, right? Naming is equivalent to drawing. I mean, they're one and the same thing, right? If you know how to draw something, then you know its name, right? If you know its name, then you are able to draw it, right? But I'll tell you to keep on practice and practice more of this. Okay, let's try to name this alkyne. So how do we name this alkyne? So obviously we are going to do the same methods. We are going to start from the side that is closest to the triple bond now, right? So this is 1, 2, 3, 4, 5, right? So again, this branch is coming on, this triple bond is coming on carbon number 2. So this should be a 2 ion, right? But what is the parent name? What is the longest chain? 5 carbons. That's a pent, right? So putting everything together, this would be a pent 2 ion. This representing that these are alkynes, and also the position where the triple bond came on, right? As simple as that, right? That's how we can do these alkynes. So hopefully you enjoyed this session, and I also know that you are going to like and share with your mates. Before you go, please subscribe so that you can keep on enjoying great content from us, and also that you keep on making these videos if you are subscribing, right? So see you on the next one. So we are going to deal with alkyl halides, aldehydes, and ketones at the same time, right? So they are more like similar. So see you on the next one.